Let's talk a little bit about balancing chemical equations. Any chemical process has to follow the law of conservation of mass, which is a feature of our universe, that matter can neither be created nor destroyed. And in chemical reactions, we've already talked about how all we're doing is rearranging the atoms. And so it stands to reason that in any chemical equation, you have to have the same number and types of atoms as when you started. Because again, you're just rearranging the Legos, you're not creating or destroying any of those Legos. And so here is what we would call a skeleton reaction for the combination of iron with oxygen gas to produce an ionic compound, iron 3 oxide or ferric oxide. When you look at that, you have to go through and figure out how many of each atom you have on both sides so that you can balance out numbers and types of atoms. So we start just by going one element at a time and seeing how many you have on each side and sorting out how that's going to go. So there's one iron on the left side. There are two irons within the compound Fe2O3, and so we are going to add a coefficient of 2. Before you can balance a chemical equation, you first have to make sure you have all your formulas written correctly. And formulas are balanced by subscripts. Equations are balanced by coefficients. And once you get your formulas written correctly, then you want to make sure that you don't mess with any of those subscripts, that you only balance with coefficients. So let's keep going with this one. So first we got the irons balanced. Now look at the oxygens. So I have 3 oxygens on the right side and 2 on the left. So at this point, what you're going to look for is the least common multiple. What's the smallest number that both 2 and 3 go into? And if your math brain is on right now, you'd have sorted out that that's 6. So we're going to need to get 6 oxygens on the left. That's going to be a coefficient of 3. We need to get 6 oxygens on the right. But in the process of balancing the oxygens, I just threw my irons out of whack again. 2 Fe2O3s is going to give me 4 irons. So I'm going to have to go back and replace that too. And so that's how you would go about balancing that equation. So basic process. Always start by writing a skeleton equation and making sure you get your formulas correctly written. Here you want to certainly keep in mind any of your diatomic elements. That's one of the big ways balancing equations goes sideways. If you have, for instance, fluorine as one of your reactants and you don't write F2, you're going to have trouble balancing things. Once you get that skeleton equation with the correct subscripts on correctly written formulas, don't mess with any of your subscripts. All reactions are balanced using coefficients. Balance one atom at a time until the full equation is balanced. And sometimes after you've balanced the first and then the second and then you balance the third element, you'll find out that it may have messed up something and you'll have to go back and double check. That's perfectly fine. If you get into a situation where you balance one element, you balance the next element, which messes up the first element, you got to change it, which messes up the second element, you got to change it. If you get into that kind of endless cycle, it's almost certainly because you didn't write a chemical formula correctly, and go ahead and double check that. Again, important. Subscripts balance chemical formulas, coefficients balance equations. You can't just go around changing subscripts to get an equation to balance if it's going to mean you don't have a correctly written chemical formula. So let's do a couple of practices here. So we have magnesium metal reacting with aqueous titanium 4 chloride to produce magnesium chloride and titanium metal. So see if you've got 4 different substances here, magnesium metal and titanium 4 chloride, and you are producing, that tells you to write the arrow, magnesium chloride and titanium. So see if you can get yourself a skeleton equation for this chemical reaction. You should pause the video and try that. Okay, so if you pause the video, magnesium metal is going to tell us that we have solid magnesium. Metals are generally solid at room temperature. Titanium 4 chloride, that means titanium has a 4 plus, chloride has a 1 minus. And so it will take 4 chlorides to balance out 1 titanium. And it tells us that that is aqueous or dissolved in water. So we have a solution of titanium chloride and we're going to add magnesium to it. In this reaction, which we'll learn about reaction types later, the magnesium is going to replace the titanium in that compound and form magnesium chloride. Magnesium is a 2+ and chloride is a 1-, so it's going to take 2 chlorines to cancel out 1 magnesium. And so we get MgCl2, and that's going to be AQ. And the other product is titanium. Again, it's a metal, so it's going to be solid. If you have an element, you can just look at the periodic table. Most of the substances on the periodic table are solids. Your noble gases, a couple of your halogens, nitrogen, oxygen, those are gases. There are only 2 liquids at room temperature, bromine and mercury. So everything else on the periodic table is going to be a solid. Now we have a skeleton equation. We need to go ahead and balance it. So there's 1 magnesium on the left. There is 1 magnesium on the right. So we're good there. There's 1 titanium on the left. There's 1 titanium on the right. We're good there. There's 4 chlorines on the left, but only 2 on the right. So we need to double the number of chlorines. To do that, we have to put a coefficient out in front of the magnesium chloride, which now means my magnesiums are out of whack. I need to get a 2 on the other side to get the magnesium balanced. And that's how you go about writing a skeleton equation and then balancing it. Let's take one more stab at it. So, I'm going to take a look at this one. Go ahead and read through that. See if you can figure out reactants and products. Try and get your states of matter and try and get yourself a balanced chemical equation. Go ahead and pause the video and give it a try. Okay, so notice this one is flipped. Sodium hydroxide and hydrogen gas are produced. That means we're starting with products, so you have to read context here. Sodium hydroxide and hydrogen gas go on the right side. If you got that flipped, you might pause the video again and see if you can make that correction. And they're produced from a reaction of sodium metal and water. So we're going to put sodium metal, again, metal's generally solids at room temperature. Water is a liquid at room temperature, so H2O liquid. They're going to produce sodium hydroxide. Sodium hydroxide is soluble in water. We will get to how you decide whether or not something's going to be soluble in water. And since we know we already have water in this system because we're adding sodium to water, that anything that will dissolve in water is going to be AQ. And then hydrogen gas is my other product, and you have to remember that hydrogen is H2. You might make any corrections to your skeleton equation and then rebalance if you need to. If your skeleton equation looks the same as what you have in front of you here, then we'll go ahead and check the balance. But pause and make any fixes that you need to fix. Okay, so we start with the fact that we have 1 sodium on the left and 1 sodium on the right. We have 2 hydrogens on the left and 3 on the right, so we're going to need more hydrogens. And I'm going to start just by doubling that. And I know I have to double that one because otherwise I'm going to end up in any other configuration with an odd number of hydrogens. And since the left side has an H2, we know it's always going to be even. Since I doubled that NaOH, that means I need more sodiums. And now we'll go in and look at the hydrogens. I've got 2 hydrogens on the left and 4 on the right. So I'm going to need a 2 there. And then check the oxygens. We have 2 oxygens on the left and 2 on the right. And so we are now balanced. Oftentimes looking at this, if someone asks you what the balanced equation is going to be or what the coefficients, you can just say 2, 2, 2, 1. Again, if there's nothing in front of a compound or an element, that means the coefficient is 1. And that's how you balance chemical equations.